Okay, let's go to different types of operating system. So yesterday we have seen different types of operating system. So one of the operating system is called batch operating system. Batch operating system was used previously in the early 80s and late 70s when actually your computer system come into the existence. So how we can describe the batch processing? We can describe the batch processing with this particular diagram. Here we have CPU and some IO peripheral. So you can understand that these two are your resources, okay? And your memory is also there. So what you assume that all the jobs are there in the main memory. So assume that. So this is your main memory. So I'll just initiate. This is your main memory. This is your CPU. This is your IO. And what will happen in the batch operating system is individual will give their jobs, give their programs to execute in the CPU, and they will go and take a nap, take a rest, and they will again come up and see whether their job has been done and the result has been given or not. So previously, with the punching cards and all, they will put the jobs into the CPU, and from there only they will get the result. So the jobs will be given to the CPU. So definitely J1 is coming at very fast. So the job 1 will go to the CPU, and then CPU will execute this particular program or the job. And in between, if the job is required some IO devices, so the CPU will give control to the IO device. And in the CPU, there will be no J1 or there will be no program at all. But the CPU will not going to take J2 or the job 2. Why? Because it is a batch operating system. It will execute only one program at a time. And if a program is required the IO, so it will go to the IO. So the operating system will handle one job at a time, either in the IO or in the CPU. Okay. So that's why this particular is not an interactive operating system where even though CPU is free, we cannot allocate another job. So waiting time of the job is more here in the batch operating system. Let's go to the second operating system, which is called multi-programming operating system. So what is the multi-programming operating system here is, the multi-programming operating system is an enhancement of the batch operating system. So when the person has given the job and this job is there resided in the main memory. So I'll just draw the main memory. So it is in the main memory, and the job 1 will be executed in the CPU because it is a first come first serve, right? So job 1 has come first, so CPU will be given to job 1. And if job 1 required any IO, so it will go to the IO. Once the CPU is free, CPU will take the next job from the job pool and it will execute it. So it is just like a multi-programming operating system where multiple program will be handled by the operating system. Getting it? So multiple program could be handled by the operating system, not the CPU. CPU is a resource, IO is a resource, RAM is a resource. Multiple job could be handled at once, at simultaneously in the multi-programming operating system. And it will be handled by the operating system itself. Now, the third type of operating system is called multitasking operating system. So when the job will be submitted for the execution, so definitely it should be in a RAM or in the main memory. So these jobs will be executed in CPU. And what happened in a multitasking operating system is will not execute the job up to its burst time. Burst time is the time taken for any program to execute. Let's say we have a program will take, let's say, 10 millisecond. Another program which is taking 20 millisecond. Another program which is taking 6 milliseconds. So every program is associated with the burst time. But the CPU is not executing one program at a time fully. What it will do is it will preempt the program in after some time. Let's say if we are using the round robin fashion, so one job will get, let's say, 2 seconds, another job will, sorry, 2 microsecond, another will get another 2 microsecond, another will get 2 microsecond. In that way, what will happen is every job will be interacting with the CPU, and the CPU will interact with all the job in a round robin fashion. So in a multitasking operating system, we are entertaining, it is a multi-programming type of thing, but it is also an interactive operating system. Okay. So here the waiting time will be decreased in a multitasking operating system. And in today's operating system, whatever operating system we use is a multitasking operating system, where we can open different file at a time and different program at a time, and we can run all those programs at once. Now, the next type of operating system is called multiprocessing operating system. Okay, so this is an example of multiprocessing operating system. Okay, I'm not going to write it. I'll just write multiprocessing here. MP, multiprocessing operating system, where operating system could handle the hardware where we have more than one CPU available. Okay, more than one CPU means in today's computing world, we do not see only one CPU, one core CPU. We see either dual core or a 4-core or octa-core, that is 8-core, 16-core, 32-core, 64-core, in that way. So if we have multiple processes available, so definitely these job, whatever we put into the RAM will be allocated the resources, because the resources is available. And these resources is again work as a multitasking. Means if there is a processor 1 and given the job J1, so J1 will have 2 seconds, and after that J5 is there, so J5 will get 2 seconds. So in that way, you understand that these type of systems are very fast, or these type of operating system are very fast. Very fast. How we can say very fast is every program that we run, or every application that we open, or that we use in our system will get the CPU, so that we understood that every program is getting the CPU and they are executing. So no program is going to take much time for execution. So this is called multi-processor or multiprocessing operating system. Okay. The last operating system is called a real-time operating system. So real-time operating system is based on its what we can say, it's a time deadline. So every job or every process or every program is associated with the deadline, or with the you can say there is a deadline for executing that particular program. So if program is submitted to the CPU, so in the RAM only will arrange the job based on their priority. Based on their priority means which is required right now, means whose deadline is nearer. That particular program will if a job is executing after its deadline, so it is of no use. Just like your missile systems, or just like your rocket, or if you have a space shuttle. So all these systems need to run in the real-time operating system. So if an event has to be triggered in this particular system, it has to trigger within the deadline. If it is triggering after the deadline, so it is of no use. So in the real-time operating system, every process is associated with the deadline. So all jobs, process, task is associated with some deadlines in the real-time operating system, and that deadline is associated with the process.